Hello everybody, my name is Jordan Grenat and I'm the author of the Elm package Regression Testing. This video is here to introduce you with the philosophy behind the regression test. So let's begin. For that I will use the code base from the trivia refactoring kata, which is a kata is a little exercise of code. Here the goal is to refactor a very bad code base into something that is much nicer without breaking anything. The code is really bad, so we will see that in a few minutes. And this is basically a trivia quiz application. So let's have a look at the application in Elm Reactor. So if you open the only file, which is game.elm, you can see nothing. But if you open the console, you can see that in fact the game is happening with console logs. So okay, we will continue with that. You can see that there are 3 players: Chet, Pat, and Sue. Each of them will roll 2 dice and get a score. So they move from the proper amount of cases. Then they have a question and they can answer it correctly or not and win points. Once they have enough points, they can win the game. So here, Chet has won the game. So let's have a look at the code base. So there is only one file, which is game.helm. And we can see that it's not really good code because we can't understand exactly what happened everywhere. So let's just have a look at the model. We can see something here. So we have an array of players, which is only an array of string. So I guess it's an array containing the usernames. Just below, we have another array which is used to store the positions of the players. So I'm starting to wonder if what happens if the array have not the same size. So maybe that's something we should refactor. We'll see that in a few minutes. There are many things wrong in this file, so we won't try to fix everything. I will just show you some small refactorings to show you how to use my package. If you want, I encourage you to try yourself on this refactoring. The link will be in the video description. So, something that I don't like, for example, is that we have here the getCurrentCategory function, and it just returns strings. What I would like to return here is something like category. So we will try that in a few minutes. And if you have a look at this function itself, it's quite messy because you have a lot of conditions. And if you look at them, you can see that it's basically just a modulo on the position of the player. So each four positions, it's a pop question, etc., etc. So okay, we want to refactor this, but we don't want to break everything. And as the code is really dirty, really bad, we don't know exactly what happened inside this code. This is like a big black box, and we don't know exactly what happens inside. So we will need something to help us refactor this code without breaking anything. And of course, for that, we will need some tests. So let's add some tests. So I'm using Helm test, which is already installed, and I'm just saying, okay, just init the test on the project. You can see that it has generated an example. We don't need that. So I will just remove that. And what we will try to do is use a regression test. And first, let me explain what we will do. Regression testing is something really simple. We will generate randomly a lot of tests, sending some inputs to our program and registering some output from this program. So we will first create a generator to generate tests. Then we will send a lot of inputs to the program, get a lot of outputs. We will save both the input and the output. We will then refactor the code. And once the code is refactored, we can run the test again with the same input that we saved. And we can compare that the outputs are the same that the output we did save. So let's try that. First, let's install my package. So Elm install regression testing. Okay, perfect. Now we will need to create a first file. This file will explain to my tool how to generate some tests. So we'll call it regression test generator. Okay, and we need to expose one thing. Which is a regression test generator program. Let's import it. Okay. And it takes two arguments as tip, the model and the message. Here I'm just importing the model and the message type of my game. So let's create that. We will test the update function of our program, so let's use the update function of the generator that needs many things to work. So let's have a look. Here in this record, we need many things, so let's just add some debug.todo. So we will need a generator for the model, a generator for the message, the update function. This is easy, we can just give the update function of our program, a way to encode the model, a way to encode the message, a port for communicating with the program, so we will just create it now. So this becomes a port module, and we will just declare output port. The name is important, so keep that name. And say that it's something that take json.encode.value. Okay. So this is a basic port, and we just need to give it to the generator for it to run. And we need to specify how many tests we want to generate. Let's say we want 300 tests to be sure we don't forget anything. Okay, now we need a model generator. So it is a random generator with Elm random. So let's import Elm random, and it should generate our model. For now, I don't want anything fancy, so I will just generate always the same initial model, because in our program it's always the same model. So let's use that. It's done. Now let's create a message generator. So it's a generator for the message type. If you go have a look at the message type, you can see that we have two different messages. So I will just keep them here. This one is a bit more complex to generate because it needs 2 arguments. So let's begin with that. So we will just generate a dice rolled message. Okay, for that we need a dice value between 0 and 12 because there are two dices, and a boolean to know if the answer, see if the question was answered correctly or not. So okay, great. Now we have a dice rolled generator, and we just need to get it back. So we have our dice rolled message, and we will just generate either that message or a new turn message. Okay, so this is our message generator. Now we need a way to encode into JSON our model and our message. So let's create that. Okay. And I'm using IntelliJ, so thanks to the amazing plugin of Keith Ladzuka, I hope I say that correctly, I can generate this encoder. Perfect. So let's use that. And I just need the message encoder. So once again, my message, and okay, this one is a little more complex, so I will just generate. Sorry, yes. So it's not really important for this video, so let's just generate it quickly. And this was the last thing that we needed to create, to generate our test. So now we can install the CLI, so let's use npm and install our package, so Elm Regression Testing. Okay, so now we have access to a new tool that will allow us to generate the test. So just give the path to your generator, and small typo, and here we are. It has created a new file which is named by default generated regression test data, and we can have a look, and you can see that it has generated a lot of model and messages and stored them as JSON inside our file. It is stored as JSON because if we change the model, we will be able to decode it into the new structure. We will see that later. So we have our test. We can, we don't need the generator anymore, and we can just create a new file which will be the runner of our test. So let's create a regression test runner. Okay, and This time we will expose some test. So this time we will use the runner part of the package. So regression test dot runner dot update, because we're still testing an update function. Okay, and this function needs three things. Okay, first a model decoder, a message decoder, and our update function. So this one is quite easy. Okay, so and as a last argument it needs the test data from our generated file. So okay, as you can see, I'm importing the test data, this one, and using it to generate some test. So let's create the model decoder. This is easy thanks to the IntelliJ plugin. And let's do the same for the message. Once again, it's a little bit complex, so let's just generate it quickly. So I'm just decoding the type field and decoding the proper message. As you can see, sometimes it can fail because it's JSON. We don't know what is in it, so that's okay. And we can give the model decoder and the message decoder to our function. So let's try to run our test. And as you can see, we have now 300 tests that pass, of course. So we've just generated like 300 tests that will cover hopefully each case of the program. So if we break something, we will know immediately. So let's start the refactoring of our program. So first, so we want to introduce a new type, which is called category. So let's do that. So it's either pop question, science questions, rock question, or sports. Okay, and now we can replace the return type of this function by the category type. Okay, perfect. Now we need to replace every string by its value. So here pop becomes pop. Here the string science becomes only science. The same for sports. And for rock. Perfect. If we go have a look at our program, it still works, so it's perfect. But did we break something? No, everything is fine. Your tests are running and passing, so it's okay. Let's do the next thing. As I told you, this looks like a big modulo, so let's try to do that. So we will need an array of our categories. So array, and let's list our categories. So pop, science, rock, and sports. Perfect. Now we need to calculate the modulo from the place. So let's use mod by. We need the length of the categories. Categories, and we will use the place. Okay, and now, so let's forget about that for now, and we just need to return the proper category. And this is a maybe, so we need something that is not really beautiful, but it will do for now. Let's return rock by default, because this was rock before, so let's do the same. Okay, so does it work? Yes, it still compiles, so everything is fine. Let's run our test. Oh, we can see that we have like 113 tests failing. No, 187 tests that are failing. That means we broke something. The program is still correct, but we broke something. So let's have a look. And if you look, you can see that the order of the categories is not the same in my code. Here I have pop, science, sport, then rock. Here, rock is not the last one. So if we fix that and run the test again, this time it's fine. So as you can see, even a small breaking chance that could easily be not seen, you can notice it thanks to the regression test. So that's perfect. Now let's try something a little bit more complex. So as I said, we have an array of usernames and many arrays that for me should be with the username. So I think the best way to start is to create a player object, a record, that will contain all this information. So let's start with only the name, which is a string. This is a first small step to go to the better model. So let's replace here our string by a player. So now you can just follow the compiler that will say, okay, here you have a record and not a string anymore. So let's just say, okay, I want to take the name. Okay. Here we are trying to add a new player, so instead of just the name, we will add a record. Perfect. Here we are trying to access the name, and it's the same here and here. So now we don't have any compilation error. So let's try to run it. Perfect, that works. Let's try to run our test, and this time this is failing because we've changed the model. So our decoder is not correct anymore because we're trying to put a string into the players field, which is now an array of player. So we just need here to replace the player decoder, the string decoder by a player decoder, and create that. And remember, in our test data, this is always strings. So we need to convert this string into a player record. So we will decode a string, and then we will map it into a player. And here it is. We've transformed the structure of our model, and yet we can still use the generated test to check what we've done. Okay, perfect, this pass. So as I said, there are a lot of things that you can improve inside this code base. We will stop here right now because that's all I wanted to show you. Don't hesitate to ask any question on Slack or Discourse. My username is jgronart if you want. And thanks for watching.